So far, we'll be talking about circuits in direct current. As a matter of fact, I never defined what direct current is and what alternating current is, because I basically define the current as the flow of electrons in from a way to the other. And in each and every circuit, I assume that we had a battery with this end with a plus, this one with a minus, and something like, I don't know, a resistor and whatever, with the flow, with the current flowing in this direction, in this direction, and in this direction, and in this direction, all the way back to the power supply. Now, before I get into the detail, you gotta know that the current flowing in this direction is called DC, which stands for direct current, DC. As opposed, we have another type of current which is AC, alternating current, which is the one that you get from your socket in your house when you plug things. In order to better describe what alternating current is, I gotta talk about how the current is produced and electric energy is produced. So let's crack on. Let's suppose that we are in, I don't know, at the Hoover Dam in LA, California. It's basically a dam that gives power to a lot, really a lot of people in the States. And let's suppose that we have some sort. This is the dam. Yeah, it might. I never. I'm never gonna be able to draw like. Okay, so this is the dam, and we have like water all the way up here, and then it's gonna flow to. This is a very simplistic one, but it just to make you understand. And basically, it's gonna flow to here. Okay, so from a higher potential to a lower potential, it's gonna go through the dam and it's gonna make something rotate. But I'm not really interested about this because this is like one of the very common way in which we generate current. But this is just to explain you what AC is. So now we said that the water is gonna flow through. Now at the inside the dam, we're gonna have. I'm gonna try not to screw up the drawing I'm gonna make. So yeah, I'm just gonna do another circle, another internal circuit, like so. And then I'm gonna have I'm already screwing up the circuit. The drawing, sorry, not the circuit. I used to draw circuit instead of these things. So, 1, 2, 3, 4. Yeah, I got 2 left. Yeah. And the other one facing the opposite of this one. These should all be identical. I don't know why. I'm just an engineer and I don't draw those kind of things. Okay, all right. So, I'm gonna use this color here. I'm gonna have something like this, and then getting all the way to this other side like this. Okay, let me get a different color like like this one. So I have like come on, I need this color. Okay, then going like this is gonna go like this, and this is one is gonna go all the way to here. It's gonna be like this. It's gonna go down all the way to here. And let me get another color like blue. I like blue. Blue is fine. Can get this one. I don't know whether you. Yeah, it looks almost like black. Doesn't look so much blue. But anyway. This one is gonna go all the way to here like this, and like can get it from here to there like yeah, I'm gonna don't want to screw this up. Okay, so what's inside this? Well, I'm basically gonna have, can I have, yeah, I'm just gonna use, let's suppose that we have something like, what color can I use? I can use this for the north and this one for the south and something in between just to let you know that it's locked. And the magnetic field like this is my magnetic field. Now the reason why I drew this is that when the water gets through here, it's gonna, you know, it's gonna rotate a rotor which is made with the magnet. So essentially it's just gonna rotate, make magnets rotate. So from here you are basically gonna have something that rotates, okay, and goes like this, 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 and so on and so forth. So while this one, this little guy here, this magnet is rotating, okay, you know that because of Lenz's law, a magnet that rotates, well, when you make current go through a wire, as I said at the very beginning, you're going to have, for instance, if the current is going to go in this direction, okay, you get your thumb in this direction, you're going to have a magnetic field forming in this direction, okay? This was like the very basic at the very beginning, right? You remember that, right? So instead, if you do have a magnetic field, okay, so you don't have current, but you do have a magnetic field, then you're gonna induce a current passing through the wire. And this is exactly what's gonna happen here, because you're gonna have the dam and the water flowing through the dam, making the dam, you know, the magnet rotate. So this magnet here is gonna rotate, and the rotation of this magnet, there are those coils here. Each and every coil are connected, are coupled together, and they are 120 and 240 degree apart. So basically 120, 240 degree apart. Even though it doesn't look like that from my drawing, but and as the magnet is rotating, it induces an electric current, because it's basically gonna make the electrons flow and move. Okay, so now let's suppose that like the north, like the magnet is like this with the north and with the south. Okay, then it's gonna rotate. Okay, so the current is gonna flow in this direction, until the magnet is like something like this. And then it slows down. Okay, so then the magnet is gonna be with the in the opposite side, with the south and the north, because it completed the rotation, and is gonna rotate in the opposite and go back here. So as it rotates, okay, because of the water flowing, the current is gonna go in this direction, then it's gonna stop, and then it's gonna flow in the opposite direction. So basically the current is gonna go here, it's gonna stop, and it's gonna go back here, then it's gonna stop, it's gonna go back here, and it's gonna stop, and it's gonna go back and forth, 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 as the magnets rotates. What happens then is that you are basically going to have an alternating current. So a current that alternates at about 60 hertz in the US, or about 50 hertz in the UK. So 60 times per second in the US and 50 times per second in the UK. If you're gonna plot this as a graph, you will have something like that looks like this. You will have, I'm gonna make a graph. Whoops. Okay, so if this is my graph, so I'm gonna plot this. I'm gonna say, okay, let's start from the red one. Okay, so remember, those are shifted 120 to 240 degrees apart, but let's start from the very simple one. So the magnet is rotating. Okay, it's rotating, rotating, rotating. So I'm gonna go in the first direction. So I'm gonna increase the speed, increase the speed, increase the speed, and I'm gonna get to that direction. Then I'm gonna decrease the speed, and I'm gonna go back in the other direction. So if I gotta plot this as a sort of graph, I would have that the current is flowing in one, well, the magnet is rotating, so the speed is growing, 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 growing. Then it's gonna decrease as it's gonna stop. So it's decreasing, 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 decreasing. And it gets to 0 because it's ready to change direction and go not in this way, but it stop and go in the opposite direction. So it will go all the way down, and it's gonna be fast, fast, fast in the opposite direction, and it's gonna slow and change direction again. And you will basically have this. Now, what happens to the blue one? Well, the blue one is experiencing something different because it's not like the red one is a few degrees apart. So it's gonna experience and it's gonna have a speed going in one direction, then slowing and going the other direction different. Because, you know, when the north and the south are like this, the red one is going to experience the speed. But this position here is going to be the same for the blue one, but when the blue one is when the magnet is in this position with the north and south. Okay, so north, south, north, south, and the same goes for the green one, north, south. So this position corresponds to a different effect to the red one, and a different effect to the blue one, and a different effect to the green one. So the blue one, what's going to happen to the blue one? Well, the blue one is going to have a certain velocity which is different from the one of the red one, at a different point in time. So it's, I suppose that it's here is already going down, and then it's gonna change direction and go all the way up, and then is it at the same height? No, it's not. And then go down again. Okay, so it's gonna go down. Yeah, it's not the best graph ever, but who cares? And then the green one, it's gonna feel a different effect, as I said before. So it's gonna be at a different speed and in the different direction at the given moment in time. So the green one is gonna be like going up and then going down, like so. So from here, this is 0 degree. Here we have 120 degree, and here we have 240 degree. So they are basically shifted, as you can see. And this, my friend, is the AC three-phase. So we have AC, alternating current, it's going to have three phase, and each of those is called a phase. We have one phase, two phase, three phase. Everything is because of the magnetic field that induces an electric field, which basically is current flowing. And as the magnet rotates, a current is generated. But as you can see, since those are shifted 120 to 140 degrees apart, they're going to have a different speed and a different, since they're going to go in one direction and then in the other direction, they're going to have a different speed at the same moment in time. So that's why you get three-phase current. So this is the very basic idea. After this, I'm gonna talk about transformers.